Using trig inverses. We're going to do 3 examples here where it's just asking you for angles whose cosine is, whose sine is, or whose tangent is a certain answer. Now, I'm going to be using this unit circle for all 3 examples. I'll do them separately in different colors. We're starting off with cosine. Now, when we're taking the cosine of an angle and the answer is negative, looking at our unit circle, cosine is going to be negative in the third and the second quadrant. Now, when it does not specify the interval that you're finding that angle measure for instance, it usually says from theta it goes from 0 up to 2 pi, it gives you some sort of interval. If it doesn't tell you the interval and you're finding the cosine of an angle and the answer is negative, our answer is going to be coming from the second quadrant. You're always looking for the smallest or the positive angle. So looking at this example, we know that it could be in the second or the third quadrant. Well, if the cosine value is a negative radical 2 over 2, making that triangle, we're going to be able to see now, if we pull that triangle out, negative radical 2 over 2, this is my right angle, it must be a 45, 45, 90 triangle. Because in the unit circle, the radius is 1, which means this side would be radical 2 over 2. Well, if this is a 45-degree angle, and this is 180 degrees, that means 180 minus 145 is going to leave me with 135. Therefore, the measure of this angle from this initial side to this terminal side would be 135 degrees. Usually your answer is looking for in radians. If it doesn't specify, then you can just write 135 degrees. If it does give you an interval, or if it does say put your answer in radians, you would just multiply by pi over 180, and we would wind up getting 3 pi over 4 radians. Now, if it asked you for, let's say, all of the possible angles from 0 to 2 pi, then we would have to find this angle as well. Again, if this side is negative radical 2 over 2, and this is 1 because it's inside of the unit circle, this side must be negative radical 2 over 2, which means this has to be a 45-degree angle. That would be 180 plus 45 degrees, which would give me 225 degrees, which again, then you would convert into radians. But if it just gives you angles whose cosine is negative radical 2 over 2, you only need to tell me one answer. It should specify, though, the interval that it wants answers from. So you find as many as you need to satisfy that given interval. Now again, cosine, and it's a negative answer, that's going to be chosen from the second quadrant because this is 135 degrees. This we said would be 225 degrees. We're always trying to pick the smallest angle, and we're trying to stay positive. So if we don't have to choose a negative angle, if it's not the smallest absolute value, we're going to be choosing the smallest absolute value, and then if we have a choice between positive or negative, we'd pick positive. But for cosine, if the answer is negative, our answer, if we're only choosing one, will be coming from the second quadrant. Also, keep in mind that cosine is an even function. So even when we're picking a negative angle value, the cosine value would still be the same. So whether it's 135 degrees or negative 135 degrees, the cosine value is the same because we're going out the same distance. Just something to keep in mind for any cosine function. It's an even function because whether the angle is positive or negative, the cosine value will be exactly the same. Looking at the next example, angles whose sine is negative 1/2. Well, in this case, again, here, sine, and it's a negative value. So that means that it must be falling in either the third or the fourth quadrant. Now, for any sine of an angle where it's negative, the smallest angle is going to be in this fourth quadrant. So like I said before, you're either picking the smallest absolute value or the positive measure. In this case, the positive angle here is going to be too big, so we're going to pick the negative measure down here. So the sine value is -1/2, which means the distance down is -1/2. If it asks you for more than one angle, or it asks you on the interval from 0 to 2 pi, then you'd have to change your answers. But in this case, it's just asking for an angle whose sine is -1/2. Well, since this would be forming a right triangle, across from the -1/2 would have to be the 30 degrees, which means this would have to be 60 degrees, which means that this angle measure would be a -30 degrees. Again, if they asked for this in radians, you would just multiply it by pi over 180, and you'd get, in this case, that it would be a -pi over 6 radians. Sine is an odd function, meaning that if I plug in a positive angle measure, the negative angle measure would negate my answer. So in other words, the sine of 30 degrees would be +1/2, but the sine of -30 degrees is going to be -1/2. So it's the same distance, but because the angle measure is negative, it negates the answer. Finally, we have the tangent of an angle, and the tangent measure is going to be negative. So here we have a -1. So we're looking for the tangent of an angle, and the answer is -1. Well, we know that we're going to be looking either in the second or the fourth quadrant because that's where tangent is negative. But again, in this case, we're going to be focusing on the fourth quadrant if we're only looking for one answer, because we want the answer with the smaller absolute value. So even though this would be a positive angle, we're going to be looking at the negative angle because it has a smaller absolute value. Well, we know that tangent of any angle is the same thing as the sine of that angle over the cosine of that angle. Which means if sine over cosine is -1, that means you're basically dividing it by its opposite. So that means you're going out as far as you're going down. So the cosine value, if it's positive, then the sine value would be negative, but it's the same distance. Same thing if we were to look at the second quadrant, the cosine value would be negative, the sine value would be positive, but it would be the same distance. Which means, since this is a right triangle and these two distances are congruent, the angles opposite them must be congruent. So that means this is a 45, 45, 90 degree triangle, which means that this is a -45 degree angle, which if we were to write it in radians, we would just multiply by pi over 180, which would just give us pi over 4 radians as our answer. Now again, tangent is an odd function because the tangent of a positive angle and the tangent of a negative angle are going to be the same distance, but if we have the tangent of a negative theta, it's going to negate the answer of whatever positive theta was. So sine and tangent are our two odd trig functions, and cosine is our even trig function. When solving trig equations, we want to simplify as much as possible and get the trig function by itself before we solve. So here we have a binomial times a binomial. So what I'm going to do is simplify this. Now whether you were to FOIL this out and then simplify from there by solving, getting sine by itself, taking the square root of both sides, you'd still wind up getting the same answer. This right now is factored and it's equal to 0. So all you have to do to solve is break it apart and set each part equal to 0. We don't need to simplify here because it would be the same. If we simplified, we would wind up either factoring or solving in another way. So on the left-hand side here, we're going to add the 1 to the other side. We're going to get sine of theta now equals 1. Over here, we subtract the 1 to the other side, and we get the sine of theta equals -1. Well, looking now on our unit circle, the sine value is the y value. Sine is +1 only at this point. Sine is -1 only at this point. So this is a 90-degree angle, which if we were to convert that into radians would be pi over 2. So theta could equal pi over 2. Now this is a 270-degree angle because I'm going from 0 up to 2 pi. That would be given to you as well. I have to give you the interval, otherwise your answers could keep going on forever and ever. So this angle is 270 degrees, which in radians is going to be 3 pi over 2 radians. In this case now, those would be our two final answers. And again, the interval would be given to you from the start. If they told you just to go from, let's say, 0 to pi, then there would only be one solution. If they told you to pick negative angle measures, let's say it went from -2 pi up to 0, then you would pick the -90 degrees, the -270, and again just convert them into radians. So it all depends on the interval that the equation is starting with. But for any equation, you're finding all of the possible solutions given the interval. In this next example, we're going to have to use a trig identity. Hopefully you're familiar with by now the fact that the secant of theta squared is the same thing as saying 1 plus the tangent of theta squared. We'd like to get our equation all using the same trig function if possible. Now I'm going to get it into standard form. I want it equal to 0, so I'm going to subtract this 1 to the other side, and I'm going to subtract the 1 tangent of theta squared to the other side. These are like terms because they are both squared. Think of it as like 3x squared minus 1x squared. Now that it's equal to 0, we can look into factoring. You're always looking for a GCF first. And then once it's completely factored, you break it apart, set each part equal to 0. 2 equals 0 doesn't make sense. Tangent theta squared minus 1 equals 0. I'm going to get the tangent function by itself, but it's not by itself until it's no longer being squared, so I need to take the square root of both sides. However, the square root of 1 is positive or -1. So we're actually looking at a few situations here. Well, we know that tangent is positive in the first and third quadrant, and we know that tangent is negative in the second and fourth quadrant. We also know that the tangent of an angle, the tangent of any angle, is the same thing as the sine of that angle over the cosine of that angle. Well, this means that the sine and the cosine values must be the same. For them to equal 1, anything divided by itself is 1. So looking at the positive 1 first, if the cosine and sine values are the same, then this is a 45-degree angle. Again, normally the most popular interval goes from 0 to 2 pi. So if it's a 45-degree angle and we're writing our angle measure in radians, that's going to be a pi over 4 radians. If we're looking down here, again, where tangent is positive, this is a 45-degree angle as well because it's an isosceles right triangle, which means 180 around plus 45 gives me a positive 225, which when we convert it to radians, so we multiply by pi over 180, that's going to give us a 5 pi over 4 radians. Now looking at when the tangent of theta equals a -1, over here you'd be going negative however many units left and a positive same amount of units up. So this is again a 45, 45, 90 right triangle, which means this angle is 45 degrees. So 180 minus that 45 degrees is going to leave me with a 135 degrees. And 135 degrees in radians is going to give me a 3 pi over 4 radians. Now down here, because it's a positive interval, we're going to be looking at the distance around. Again, we know that since I'm going a positive cosine over and a negative sine down, but it's the same amount. It's a 45, 45, 90 right triangle. So if this is 45 degrees, we're going to be doing 360 minus 45 because I'm going around and subtracting that 45. So this is a 315 degree angle. And 315 degrees in terms of radians, you multiply by pi over 180. And that's going to give you 7 pi over 4 radians. Finally, we have this example. I'm going to be telling you here, again, we're going to look at theta from 0 to 2 pi radians. Looking at this question, it looks like it's in the form x squared plus 2x plus 1 equals 0. Well, we know how to factor this when the leading coefficient is a 1. You set up your two binomials. Each one would get the x. This tells me same sign, both positive. Two factors of 1 that add up to 2 would be a 1 and a 1. And then you'd solve from there. It's the same exact thing here. We're going to set up our two binomials, but instead of x, it's going to be written as sine of theta. So I set up my two binomials, each one with a sine of theta, same sign, both positive, equal to 0. Two factors of 1 that add up to 2 are 1 and 1. If I were to use FOIL, I would get the line that I started with, so I know this is factored correctly. I break it apart and set each part equal to 0. Now you're going to see that we're going to end up here with the same two answers. So sine of theta, you subtract the 1 equals -1. Sine of theta, you subtract the 1 equals -1. So we're looking here at when the sine of theta equals a -1. Well, sine equals -1 only down here. This is a 270 degree angle if we look at the initial side and the terminal side. 270 degrees in terms of radians, we multiply that by pi over 180, and that's going to give us 3 pi over 2 radians. And that's it. That's our final answer here. There's only one solution.